Millions of years ago, Earth looked very different. All the continents were fused into one supercontinent, teeming with life both beautiful and terrifying. When you think of prehistoric times, you might picture a Tyrannosaurus rex rampaging through the jungle with its razor-sharp teeth. But even before the dinosaurs, there were other giant creatures ruling the Earth. Welcome to the Permian period. This was a world of bizarre reptiles with massive sails on their backs, bird-sized cockroaches and volcanic eruptions that shaped the very landscape. And it all ended in the most catastrophic mass extinction event our planet has ever seen. An event so devastating that scientists call it the Great Dying. Let's take an epic journey back in time to discover what Earth was like before the dinosaurs ever existed. Pangaea, when all land was one. The Permian period began about 300 million years ago, long before dinosaurs would evolve. In fact, dinosaurs wouldn't appear for another 50 million years after the Permian ended. Back then, our planet looked completely different. All smaller continents had collided to form one enormous supercontinent called Pangaea, taking up 1/3 of the planet's surface. The ocean surrounding Pangaea was called Panthalassa, meaning all seas. It covered the remaining 2/3 of Earth. No Atlantic, no Pacific, no Mediterranean, just Pangaea and Panthalassa. With all land massed together, the interior regions were incredibly far from any ocean. This created extreme climates, scorching summers and freezing winters in Pangaea's center, with little rainfall. The Permian period lasted 50 million years, from 300 million to 252 million years ago. During this time, life underwent dramatic changes, experiencing explosive evolution and ultimately catastrophic extinction. Time travel to the Permian. Pack a jacket. If you could time travel nearly 300 million years into the past, you'd land right in the middle of the supercontinent Pangaea during the early Permian period, and the first thing you'd notice is that breathing feels different. There was likely less oxygen in the air than there is now, maybe around 15% compared to the 21% we enjoy today. You'd still be able to breathe, but you might feel like you're at a high altitude, slightly short of breath, a bit lightheaded. Physical exertion would be more tiring than you're used to, and you'd definitely want to bring a jacket because it would likely be quite chilly. The Permian period began at the end of a major ice age, and temperatures were much cooler than they are today. Some areas of Pangaea averaged no more than a brisk 4 degrees Celsius. Parts of the southern regions of Pangaea were still covered in massive ice sheets and glaciers. The landscape would look alien to your eyes. The plants would be unlike any you've seen before. The animals would be strange combinations of features we now associate with different groups, and the sky might look slightly different in color due to the different atmospheric composition. But don't worry, things will soon start heating up dramatically. By the middle and late Permian, this frozen world would transform into a hot, lush paradise, before ultimately becoming a hellish oven that would kill nearly everything alive. The warming world. From Ice Age to greenhouse. By the end of the early Permian period, the Ice Age was on its way out. Global temperatures began rising, and Pangaea was slowly transforming into a lush world, where plants and animals started to thrive in ways they never had before. This was a volcanic world. Violent eruptions occurred frequently across Pangaea, changing the climate, reshaping the landscape, and paradoxically paving the way for new forms of life to evolve. The volcanoes pumped carbon dioxide and other greenhouse gases into the atmosphere, trapping heat and causing global temperatures to rise. As temperatures warmed, the glaciers retreated. Rainfall increased in many regions. Rivers carved new paths across the landscape. Lakes formed in low-lying areas. And most importantly for life, the environment became more stable and hospitable. The warming climate created opportunities for both plant and animal life to diversify and spread across Pangaea. Evolution was happening at a rapid pace as species adapted to fill new ecological niches in this changing world. The first seed plants, a botanical revolution. When the giant swamp forests from earlier periods began drying out due to climate change, plant life had to adapt or die, and adapt they did, in one of the most important evolutionary developments in plant history. About 290 million years ago, during the early Permian, Earth saw the very first seed-bearing plants appear and spread. These revolutionary plants were called gymnosperms, and they changed the world forever. Unlike the earlier plants that reproduced using spores that needed wet conditions to germinate, gymnosperms carried their seeds on cones. These seeds were protected by tough outer coatings and contained stored food for the developing embryo plant. This meant they could survive in drier conditions and didn't need standing water to reproduce. The gymnosperms spread across the supercontinent like wildfire. Ancient evergreen forests began covering vast areas of Pangaea. These weren't quite like modern pine forests, but they were the ancestors of today's conifers, cycads, and other cone-bearing plants. These early Permian forests were dense and strange. The trees had thick trunks and branches covered in needle-like or scale-like leaves. The forest floor would be carpeted with fallen cones and plant debris, and hiding among the vegetation were some familiar faces, or rather, familiar insects. Giant insects, the prehistoric bug world. The ancient evergreen forests of the early Permian were hiding something surprisingly familiar. Just like today, you could find cicadas and beetles living among the plants, piercing and sucking on the plant tissues for food. And you'd find the cutest of them all, cockroaches. Yes, cockroaches have been around for hundreds of millions of years, surviving multiple mass extinction events. They're nature's ultimate survivors. But these weren't the cockroaches you know today. These prehistoric versions were absolutely gigantic. Some species were the size of birds. Imagine a cockroach as large as a crow or a pigeon. These massive insects scurried across the forest floor and climbed the trees, their armor-like exoskeletons glinting in the filtered sunlight. The reason insects could grow so large during this period was primarily due to higher oxygen levels in earlier periods combined with lack of competition from vertebrate predators. These giant insects had few natural enemies early on, allowing them to grow to impressive sizes. But despite their intimidating size, cockroaches never ruled the prehistoric land, and that's probably good news for anyone with a fear of bugs. No, something much more fascinating and much more terrifying was roaming Pangaea, the apex predators of the Permian world. Dimetrodon, the sail-backed predator, the now extinct ancestor of primitive mammals called Dimetrodon, was one of the most fascinating and terrifying creatures to ever walk the earth. Despite looking like a dinosaur, Dimetrodon wasn't a dinosaur at all. It was actually more closely related to mammals than to reptiles, though it looked decidedly reptilian. Encountering a Dimetrodon would be quite a sight to behold and quite possibly the last sight you'd ever see. This ancient creature grew up to 5 meters long from nose to tail and weighed approximately 225 kilograms. That's about the size and weight of a large tiger, but with a very different body plan. The most distinctive feature of Dimetrodon was the large sail running down its spine. This sail was made of elongated vertebrae covered with skin and blood vessels. Scientists believe this sail helped the reptile regulate its body temperature, soaking up warmth from the sun during the daytime when it needed to heat up, and dissipating excess heat during the cooler nights when it needed to cool down. This temperature regulation would have given Dimetrodon a significant advantage over other animals that couldn't regulate their body heat as effectively. It could warm up faster in the morning and become active earlier, giving it more time to hunt while its prey was still sluggish from the cold. It would walk toward you like a crocodile, with its legs sprawled out to the sides rather than directly underneath its body. And it would act like a total menace because Dimetrodon was an apex predator of its time, meaning it sat at the top of the food chain with no natural predators of its own. Watch out for its mix of sharp and flat teeth. The sharp teeth in the front would slice into flesh, while the flatter teeth in the back would grind and crush. This combination made Dimetrodon an efficient killing machine capable of taking down a variety of prey animals. The therapsids, mammal-like reptiles, take over. In the Middle Permian period, a new group of animals began to dominate the planet. These were the therapsids, mammal-like reptiles that represented an evolutionary step between reptiles and mammals. They were more advanced than earlier reptiles and showed some characteristics we now associate with mammals. The therapsids had strong jaws with differentiated teeth, not all the same shape like in most reptiles, but specialized for different functions like cutting, tearing, and grinding. They had a somewhat upright stance thanks to their legs being situated more underneath their bodies rather than sprawled out to the sides. This made them more efficient walkers and runners. These animals varied greatly in size and lifestyle. Some were enormous, like the moschops, a creature that grew up to 5 meters long and likely omnivorous, eating both plants and smaller animals. Moschops was a strange-looking beast with a thick skull and a barrel-shaped body supported by powerful legs. Others were much smaller, like the carnivorous Lycanops, which was about 1 meter long, roughly the size of a large dog. Lycanops was a meat-eater with sharp teeth designed for catching and eating smaller animals. It was probably an active hunter, chasing down prey rather than ambushing it. You could meet plenty more therapsids if you stuck around for another 20 million years. During the Middle and Late Permian period, these mammal-like reptiles became incredibly diverse, filling ecological roles from tiny insect eaters to massive plant eaters to fearsome predators. The heating planet. Middle Permian warmth. During the Middle Permian period, Earth kept getting hotter and hotter. The average global temperature on Pangaea grew to about 25 degrees Celsius, significantly warmer than today's average of about 15 degrees Celsius. Volcanoes across Pangaea were continuously erupting, spitting greenhouse gases out into the atmosphere. The carbon dioxide and methane released by these eruptions trapped heat from the sun, causing global temperatures to rise steadily over millions of years. Due to the changing climate, sea levels were shifting. As temperatures rose, ice sheets melted, causing sea levels to rise in some areas. But in other regions, changing rainfall patterns caused seas to retreat. The coastlines of Pangaea were constantly changing. Despite these challenges, marine life found ways to thrive. If you were to take a dip in the prehistoric superocean Panthalassa, you'd be swimming alongside ancient sharks and primitive bony fish. These weren't quite like modern sharks. They were earlier evolutionary forms, some with strange body plans and unusual features. Many complex marine species came and went as the environment kept changing. Coral reefs existed in the warm, shallow seas. Ammonites, spiral-shelled relatives of squids and octopuses, swam through the water. Trilobites, ancient armored creatures that had existed for hundreds of millions of years, were still around but declining in diversity. The oceans were full of life, and that life was constantly evolving to adapt to the changing conditions. Late Permian creatures, herbivores and hunters. In the late Permian period, you could have a relatively friendly encounter with a reptile called Lystrosaurus. These creatures looked like a strange cross between a lizard and a pig. They had reptilian features but a pig-like snout and body shape. Unlike all the scary prehistoric monsters roaming Pangaea, Lystrosaurus was a peaceful herbivore. It was only about 1 meter long and spent its time munching on the low-growing plants that covered much of the landscape. It had powerful front legs adapted for burrowing, allowing it to dig burrows in the ground where it could escape from predators or shelter from extreme weather. Soon another mammal-like creature evolved that looked quite different from anything we've discussed so far. This was the cynodont, a transitional form that was even more mammal-like than the earlier therapsids. This cynodont looked remarkably like a giant rodent. It was about 1 meter long, had whiskers on its snout, possibly the first creatures to have whiskers, and fed on small animals and insects. It had a more efficient jaw structure than earlier reptiles and possibly even had a faster metabolism, making it more active and alert than its predecessors. These creatures represented the evolutionary line that would eventually lead to true mammals millions of years later. But they would have to survive a coming catastrophe first, the oxygen crisis, when breathing became difficult. During the late Permian, something ominous was brewing in the atmosphere. A massive increase in volcanic activity was displacing oxygen from the air and replacing it with carbon dioxide and other gases. Scientists estimate there was as little as 10% oxygen in the air during parts of the late Permian, compared to 21% today. If you could time travel to this period, you'd have a very hard time breathing in that environment. You'd feel constantly short of breath, dizzy, and unable to perform any strenuous activity. Even walking would leave you gasping for air. For the animals living during this time, The low oxygen levels meant they had to adapt or struggle to survive. Many species became smaller because smaller bodies need less oxygen. Some developed more efficient respiratory systems. And the temperature just kept rising and rising. With an average global temperature reaching about 28 degrees Celsius, this once lush prehistoric world was turning into an oven. The interior regions of Pangaea became hot, dry deserts. Only the coastal areas maintained enough moisture to support forests and diverse animal life. The stage was being set for catastrophe. The Great Dying, Earth's worst catastrophe. All good things must come to an end, and sadly the Permian period came to a particularly brutal one about 252 million years ago. About 90% of all plant and animal life on Earth was wiped out in a geologically short period of time, possibly less than 1 million years, maybe even less than 100,000 years. This tragic moment is called the Great Dying, and it was Earth's most devastating mass extinction event. To put this in perspective, Earth has experienced 5 major mass extinction events throughout its history. The one that killed the dinosaurs 66 million years ago, the one everyone knows about, wiped out about 75% of species. But the Great Dying at the end of the Permian was far worse, eliminating up to 96% of all marine species and 70% of land vertebrate species. It was the closest life on Earth has ever come to complete annihilation. What caused the catastrophe? Volcanoes and devastation. Scientists still debate exact causes, but the most accepted theory centers on massive volcanic activity. About 252 million years ago, enormous eruptions began in what is now Siberia. These flood basalts poured lava from Earth's crust for thousands of years, covering an area the size of the United States. But the lava wasn't the main killer. Massive amounts of ash, sulfur dioxide, carbon dioxide, and gases were unleashed. So much ash blocked out sunlight. With no sunlight, global temperatures dropped suddenly. This volcanic winter lasted years, possibly decades. Plants couldn't photosynthesize in darkness and cold, so they died. Without plants forming the food chain base, herbivores starved. Without herbivores, carnivores starved. The entire ecosystem collapsed. But it got worse. As eruptions continued, carbon dioxide accumulated. Once ash settled and sunlight returned, that carbon dioxide trapped heat and temperatures rose dramatically. Global temperatures may have hit 35 degrees Celsius or more. This extreme heat plus oxygen-depleted atmosphere created hellish conditions. This caused Panthalassa to lose most dissolved oxygen. Marine animals suffocated. Ecosystems that survived the cold phase died during the hot phase. Over 95% of marine species became extinct. More than 70% of land vertebrates disappeared. Even insects experienced their only known mass extinction. The world became a near lifeless wasteland. The few species that survived did so by pure luck or by having specific adaptations that allowed them to tolerate the extreme conditions. Conclusion: after the catastrophe, life persists. The Permian period and its catastrophic ending remind us just how fragile life can be, even when it seems to be thriving and diverse. The world before the dinosaurs was filled with incredible creatures, sail-backed predators, mammal-like reptiles, giant insects, and countless species we'll never know about because they left no fossils behind. But life is also remarkably resilient. Despite 90% of species going extinct in the Great Dying, life didn't end. The survivors slowly recovered and diversified. The ecosystems rebuilt themselves over millions of years, and from the ashes of the Permian extinction, a new group of animals would eventually emerge and come to dominate the planet, the dinosaurs. They evolved during the Triassic period that followed the Permian and would rule Earth for over 150 million years. The story of Earth before the dinosaurs is a story of evolution, adaptation, catastrophe, and survival. It shows us that our planet has always been changing, that life has faced extinction-level threats before and survived, and that the world we know today is just one chapter in a much longer story. If you enjoyed this journey to the Permian period, subscribe for more explorations of Earth's deep history and the incredible creatures that lived long before humans ever existed. Stay curious about the ancient past.